Welcome back to Open Med School. In the last sessions, we have discussed about the digestion of fat starting from the mouth, then the action by the gastric lipids, then in the intestine by the pancreatic lipids, helped by the emulsification by bile salts. Today, I will be discussing what happens to the bile salts and what happens to the diffused fatty acids, monoglycerides, and cholesterol entering the intestinal mucosa, how it is re-esterified, how it is formed into chylomicron, and then how the chylomicron is transported to various sites. From the mixed micelle, the lipase act on it, the free fatty acids and cholesterol are released, the bile salts get detached, it passes down to the ileum. From the ileum, it is absorbed, goes via the portal system into the liver, where it is again recirculated. This is called the enterohepatic circulation of the bile salts. 98% of the bile salt is recirculating like this. So, just will again think about what is happening in the mucosa. So all of you draw the mucosa. This is the mucosa. From the intestinal lumen, the fatty acid is entering, monoacyl glycerol is entering, cholesterol is entering. The fatty acids are activated by the enzyme called fatty acyl coenzyme A synthase or thiokinase. Fatty acyl coenzyme A synthase, and fatty acid is converted to fatty acyl coenzyme A. This will combine with the monoglyceride and is converted to triglyceride. Then we have already discussed how the formation of the chylomicron is occurring, and the chylomicrons are passing via the lymphatics. These are the four jejunal or the small intestinal mucosa. Foldings are there, and inside you can see the lacteals and the blood vessels. Chylomicrons are large particles, so it cannot pass through the blood vessels. But the medium chain fatty acids can directly enter the blood vessels. Coconut oil is an example which contains some amount of medium chain fatty acids, so without digestion they can directly get absorbed. This is the formation of chylomicrons which we have described. So in the smooth endoplasmic reticulum, re-esterification occurs. So you get the triglycerides, cholesterol esters, and the rough endoplasmic reticulum produces the lipoproteins, and the Golgi bodies help to get it attached to the chylomicrons. And this undergoes exocytosis. Hope the generation of chylomicron is clear to you. This is a larger picture of the chylomicron. You can see the typical lipoprotein, the B48. You can remember by the B48 bomber. So for the chylomicron to pass out, this ApoB48 is required. It contains cholesterol, phospholipids, and triglycerides. So this is the major lipoprotein by which fat is transferred from the small intestine. Then what happens to the chylomicrons? We have mentioned that through the chylomicrons pass through the thoracic duct and reach the systemic circulation at the junction of the subclavian and internal jugular vein, and it reaches the systemic circulation and it finally reaches the liver. So in the liver, it is converted to or used for synthesis of very low density lipoprotein. A part of chylomicrons will reach the fatty tissues or fat cells. Some of them will be utilized in the muscle tissue. So in the muscle tissue, what will happen under the fat? This will be at the bone. It will be hydrolyzed to fatty acid by the action of lipoprotein lipase. These fatty acids will undergo beta oxidation, and for the generation of energy, or fatty acids can be utilized for storage as fat. So that is the fate of the chylomicrons. In this session, we have discussed about the intrahepatic circulation of bile salts, the reabsorption of the fat, cholesterol and phospholipids by diffusion to the mucosal cells, the re-esterification in the smooth endoplasmic reticulum followed by attachment of apolipoprotein B48, how the chylomicrons are formed, and exocytosis of chylomicrons. In the next session, we will be discussing about the fate of lipoproteins and a summary of the digestion. Hope this was useful to you. Stay tuned. Thank you. Bye.